Hi, I'm Brendan Kerr, and I'm part of the Liquid Force Response redesign team. So for this project, you're probably wondering what kite surfing is. Kite surfing is a sport where you're pulled across the water by a large inflatable kite using a bar that connects you to this kite. And this bar allows you to control the power of your kite as well as steer your kite in the direction you want it to take you across the water.
Hi, I'm Alden Simmer, and I'm a member on the Liquid Force Response redesign team. So we took the Liquid Force's response bar and noticed several problems with the existing bar, mostly in part the problems are due to a lack of ergonomics on the bar ends, too high of a part count, which makes the bar more expensive and also more likely to fail in the bar ends. And we did a full breakdown of the bar, part count, and then moved on to a redesign of the bar ends, and also of the bar center to provide a more ergonomic, economical, and useful, beautiful bar. So one of the first steps in the bar redesign was to conduct a literature review, and we looked at several components of the redesign to go research online. And two of those were looking at the colors in the bar and also the grip diameter. And we found a couple articles on the grip diameter, and basically these articles were talking about grip diameters in the workplace, because no one in the kiteboarding industry, no one has any peer-reviewed articles, so we had to look in other industries. And we found that a lot of the time they like to keep grip diameters at least a centimeter below the maximum grip diameter, which is measured from your pointer to your thumb. And so what this does is it reduces the stress on your forearm if it's at least a centimeter smaller than that circumference of your pointer finger to your thumb. As well, we researched color and using color as a cue for safety. So in the kiteboarding bar, there is a right side up so that the kite will steer to the left when you pull on the left side of the bar. And so this bar has two different colors, which it can confuse the rider, and you're not exactly sure if the bar's right side up or upside down. So we wanted to get rid of the two colors and put one color on one side and one color on the opposite side. So let's say you see red, you know the danger bar's upside down, so you flip it over to the other side. And as well, we're introducing one side that has the Liquid Force logo on it.
Before building a prototype of this bar, we really took a look into what the current bar is made of. And so doing that, we did a functional decomposition and took apart the entire bar, documented what each part did and how many parts there were in the bar. And then we also did a ergonomic survey where we used 10 kiteboarders and tried over 10 different brands, current market bars that they have out there. And what we did is we had them do blind tests and rate the fit of the grip, the bar shape, and the bar center in their hands. And what we found is that out of the 3 different types of grips we found, only one was statistically significantly worse than the other 2, and the other 2 didn't have a significant difference. We did that using ANOVA analysis. And so we decided to make our bar circular, which was one of the higher 2, and also would reduce the cost and component count of the bar. The next part we looked at with the ergonomics is the bar center. And again, there was one bar center out of 4 types that was significantly worse than the others on the ergonomic survey. And so we kind of had 3 bar centers to choose from, and we stuck with a slightly larger square bar center that kind of fits with Liquid Force's current product line and their other bars, but is not too large enough that it would score low on the ergonomic survey according to our analysis. Last, we looked at the grips, but this was less of a ergonomic survey. This was more of a design survey, or not design survey, but just a design problem where the grip was super high in component count, so we really wanted to reduce that component count. There's almost 12 components in this bar end, and we limited it down to essentially one component, and that's what we have right here. For the environmental and social impacts of our redesign of this bar, what we really wanted to focus on was a component count decrease. And so what we have done is eliminated a lot of these plastic parts. There's lots of small plastic pieces that had high scrap rates. And we changed those into more of one large aluminum piece that would be casts, which has a really low scrap rate and has no waste compared to pouring plastic. And for social impacts, there's a lot of safety within a bar, and you don't want the bar to be hurting anyone. It's their user interface with the kite. So we just wanted it to be very simple, have no chance of breaking, so we built a very durable bar, and a bar that doesn't have any pieces that can cut you, and it's just a very sleek, smooth design. Economically, we believe this bar will be a lot cheaper to produce and can also sell at a similar or higher value than the old bar. The reason behind that is these cast parts are less than $1 each, and you have that lower scrap rate and less molds you need to make because there's fewer components. You're reducing the number of molds and allowing you to produce this part at a lower cost. So in the kite industry, it's very common to come out with new iterations of your product or new products every year to keep up with the changing markets and your competitors. And we believe that this bar is very customizable for new iterations, including possible different colors or diameters of grips, for example, women's or just custom orders if someone wants to have a more personalized bar. And this is a great customization because it allows postponement of your kind of work in progress, where the grip is one of the last steps in the bar. So you can assemble to order essentially and not have a bunch of different colored bars sitting in stock and need to sell or push a certain amount of those.
So for our prototype, we decided to use both aluminum and carbon fiber for just machinability and also to keep our prototype light and stiff. So for our bar center, we went with a machined aluminum part. This part was a 4-axis part that we machined in the 4-axis mill on campus. So when we designed this, we wanted to make sure we could actually machine it for a prototype. So some of the features in this, we wanted to make sure you could cast it as well, because that's what we're going to do, hopefully, for production. But the way we turned it is we cut this down to length, we turned it on the lathe, and then we put it in the 4-axis mill and did the center part. For the bar ends, we did this as it was a 4-fixtured part. It was quite complicated, but we were able to make it. In the production model, this would actually come down to the radius of the tube. So if you see here on our bar, it doesn't actually fade into the tube perfectly. This was because it was very hard to machine. So in our cast part, we would actually make this nice and smooth and feed into our bar. When we made our bar, we ended up using glue on our bar ends. We don't know if this is the perfect way to go. We still want to do more research on that. So we recommend that Liquid Force should go into some more research on what epoxies they should use, or maybe if they should even use epoxy on their bar ends. So the epoxy we used is DP420. It's a really strong high-end epoxy that we believe is plenty strong for this application. Our one worry is we might get galvanic corrosion between the bar end and the carbon fiber tube. So testing would have to be done to make sure that that's not going to occur. So for our bar end, we went through 4 iterations. We started with a very simple small bar end that we just wanted to support the actual line that comes out of the end. But as we moved along, we kind of thought we wanted to make it a little bit more complicated to just make it look really nice. So a lot of bar ends have just a piece on the inside and then the big EVA overmolding, but we found that was quite ugly and didn't want to go that route. So in the end, we came up with this bar end. For our prototype, it's all just a CNC'd aluminum piece. But in production, and what I'm going to spend next quarter designing, is a way to make this outer section here rubber. so that if you were to hit it on your board or the things, it's soft, and it would also make the bar end a lot lighter. So we'd have an aluminum core and then an overmolded rubber piece that would go around here, and it'd be nice and strong and light, and just much nicer for riding and on your hands and on your board. So currently this bar doesn't have any grip on it. Cal Poly doesn't have the means to do EVA overmolding. So on this bar there would be grip coming up to this surface here and out to this bar end where there'd be another similar lip, and that'd create a nice grip where it's seamless to your bar end surface and bar center surface. We also did some prototyping where we did cork wrap, and we actually felt this was quite strong and nice in the hand, but we're going to do some more testing and decide if this is a route we want to go.